This question is asking us to balance the redox reaction in acidic conditions. So because it's a redox reaction, we know we'll have to split the reaction into half reactions, one for oxidation and one for reduction. If we start with oxidation, we'll get C2O4 with a -2 charge becoming CO2. The easiest way to balance out our coefficients is to add a 2 because then we'll have balanced out our carbon and our oxygen atoms. But we can't forget our charges. The left side has a -2 charge and the right side is neutral. The easiest way to balance this out would be to add 2 electrons. And now we have a balanced oxidation half reaction. If we go to our reduction half reaction, we have MnO4, the negative charge, becoming MnO2. So these are already balanced, but our oxygen isn't. And the easiest way to balance this out, instead of adding large coefficients or balancing this side and having to fix it on this side, the easiest thing to do would be to add 2 molecules of H2O. Because this way, we get our balanced oxygen atoms, and then we don't really have to worry about messing with any of our manganese. So now we have 4 hydrogen, which means we'll need to fix something on our left side. The easiest way to do this would be to add 4 hydrogen. And then this will be 4 fixed. But now our charge needs to be balanced because we have given 4 here and then a negative. We now have 3 positive charge on the left side and then a neutral charge. So the easiest thing to do would be to add 3 electrons to make that a little bit easier. So MnO4 negative plus 4 hydrogen plus 3 electrons then becomes and now that we have our 2 fully balanced half reactions, we'll need to add them together to give us our full reaction. But before we do that, we have to make sure that our electrons are equal on both sides. But here we have 2 and here we have 3. So we'll have to fix that a little bit. The easiest way to do this would be to find our least common multiple. And for 2 and 3, that's going to be 6. So the easiest way to do that would be to multiply the oxalate half reaction by 3 and the permanganate one by 2 so that they'll both start to involve 6 electrons, which means that we'll get, if we multiply this one by 3 and then this one by 2, we'll get 3 C2O4 with a -2 charge becoming 6 CO2 plus 6 electrons. And then on this side, we'll get 2 plus 8 hydrogen electrons becoming so now we have that. And then now we'll be able to add all of these together, where our electrons will cancel out, and we'll be able to have our full balanced redox reaction. So if we write it all together, we'll have plus our 3 negative charge plus 8 hydrogen, then becomes 2O4 plus 6 CO2 plus our 4 H2O. So now we have our fully balanced redox reaction.